Hi there, this is Astrophysics, Surveying the Stars, Lesson 6, and this one's Stefan's Law. Relatively straightforward, this one. With a couple of example questions to work through. So first of all, Stefan's Law. The total energy per second, which is power, emitted by a black body at an absolute temperature T is proportional to its surface area A and T to the power of 4. So we've got an equation. Stefan's law, power is equal to sigma A T to the 4. Sigma is a constant known as Stefan's constant. And Stefan's constant is 5.67 times 10 to the minus 8. Units are there if you're interested. It's on the data sheet, the equation and the constant. So let's get that written down. And the equation is used, it's pretty useful to determine the surface area and diameter of stars. Alright, let's do question 1. Right, here we go. So if you want to have a go at this one, and then I'll talk you through it. So calculate the power output of the sun if its diameter is 1.39 times 10 to the power of 6 kilometers, and its surface temperature is 5,800 Kelvin. The equation, by the way, the power equals sigma AT to the 4. The temperature is absolute. So it must be in Kelvin, can't be in degrees. So we've got the constant, we need the area, we've only got the diameter. So what we need to do is get the radius, so we need to divide that by 2 and convert it into meters. So in meters, it's 1.39 times 10 to the power 9 divided by 2. So that gives us a radius that is 6.95 times 10 to the power of 8 meters. Then the sun is obviously a sphere, it's spherical, so we need to do the surface area of a sphere. So the surface area of a sphere is 4 pi r squared. So we need to square that value and then times it by 4 pi. And that gives us a surface area of 6.07 times 10 to the power of 18 square meters. Then we can finish using Stefan's law. So power is equal to sigma, which is 5.67 times 10 to the minus 8, multiplied by the area, 6.07 to the 18, and then multiply that by 5,800 to the power of 4. So it's a power output that's equal to 3.89 times 10 to the power 26 watts. So you might remember in previous lessons we did the luminosity question with the sun and we got basically the same answer. So the power output, remember, is the luminosity. Alright, let's try question 2. So if you want to go at this one. So calculate the surface area and radius of Betelgeuse if its luminosity is 4.09 times 10 to the power 31 watts with a surface temperature of 3,500 Kelvin. So again, relatively straightforward. Power, sigma A T to the 4. And we need to rearrange to get area. So power divided by sigma T to the 4 will give us that value. Then we just need to put the numbers in. So 4.09 times 10 to the power 31 divided by Stefan's constant, 5.67 times 10 to the minus 8, multiplied by 3,500 to the power of 4. So we get 4.8 times 10 to the power of 24 square meters. Alright, then we just need to do the area of a sphere equation. So area of a sphere is 4 pi r squared. Rearrange that to find r. So we need to divide the area that we calculated by 4 pi. Just put that there. And then square root the answer. And that gives a radius that's equal to 6.18 times 10 to the power of 11. So hopefully that one went okay. And that's pretty big. That's around 4 times the radius of the Earth's orbit. so about 3/4 the orbit of Jupiter. So Betelgeuse is a supergiant. Anyway, I hope you found that helpful, and thanks for watching.